Good morning, everyone. I hope you're all good. Let's just share this out with everyone in the Discord. And yes, we are messing around with compute shaders today. We're going to investigate our way of doing things. Let me just get up the chat. We have our old engine to be inspired by here, because we did actually do some compute stuff. It's kind of more of a test. This stream is going to be a bit shorter. Maybe it's going to be a couple of hours. I actually don't know yet. But effectively, we're going to try our best. There's the chat. Changes to live chat. Fantastic. Okay, so what are we doing? We have our air engine. Mostly, I believe today we're probably just going to be making notes, honestly. I don't really know the direction of things at the moment, but I will explain briefly where we're up to at least. There are my notes. We have gotten to the point, if you weren't here for the last live stream, we have an indirect draw call happening. So we have a way of doing GPU-driven rendering, which means that we can generate the draw calls on a compute shader and kind of pass on the data all the way until the beginning, like vertex shader or something. That's kind of tricky to do. So I'll kind of talk us through that briefly, just to catch everyone up with what I'm talking about. So we have 3 new buffers here and one new pipeline. I call it the particle compute pipeline. We have just a compute pipeline, and 3 buffers. We're destroying them here because we're in the destruction. And I'll talk us through what each of those do. So because we're going to be doing compute shader stuff, we need a compute pipeline, not a graphics pipeline. They're very different, but the upside of a compute pipeline is much simpler. Yes, the setup is actually a lot less overhead. And we have these 3 buffers. We have a indirect draw call count buffer, an indirect draw call buffer, and particle data buffer, right? Which I'll get into each of these. I had to create these on the fly because I don't actually have a GPU buffer creation tool yet. So the first thing that we have to do is create these. So the count buffer is literally all it's doing is it's counting how many draw calls we have. That's it. Now this is important because without this in we wouldn't be able to know. Basically we wouldn't be able to iterate through our draw calls and read from them or write to them without our count buffer. For example, if we had like 10,000, then we know, oh, we need to loop through 10,000. This is effectively a tiny little buffer that has 1 value in it. That just basically sets things up so in a compute shader we can do like a basic a for loop. Now you may think, why can't we just do a for loop in the compute shader? The problem is with the compute shader, and this is why we're going to be investigating today, is that each thread. So a compute shader runs on the graphics card, right? Let's just see if I can get a picture up. So this might be easier. So if we have, I guess we can say I'm doing a bit of studying here, bit of revision. So I don't know, NVIDIA warp, right? I don't know what I'm looking for here. I just want a picture more than anything. Like, what is a warp? There we go. Okay, this is good. Whatever this is. Hopefully this takes us to something. Nope. Okay, so we'll just look at the picture, right? Right, so we have a lot of cores here, and a core can do a particular type of graphics operation. And this is a particular, it doesn't really matter what graphics card this is. We have, each graphics card has a different architecture setup, and that's why we have new graphics cards that we have. Typically they have more things in, as the transistors get smaller. Anyway, if I say, for example, I want to run a compute shader in 1 thread, we can just run the compute shader in 1 core, right? That's fine. This is what we do at the moment. But, that's a waste of time. what we can do with the compute shader, if we're very careful, is we can get it to run on like a whole warp. This would be a warp, right? A whole section of a of the GPU, where we've got a bunch of cores that all group together. So I think it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just turn that down, perhaps. It's a bit loud for me. Okay. Yeah, so typically you have 32 or 64, and you blast through these kind of like in one go, right? We have different instances of the compute shader. They all just run like the code. The problem is the problem is multi-threading effectively, right? For example, let's just say I want to let's just come up with the simplest example. I want to add 1 to a number and then read from that number later on. So let's just say I add 1 to a number and then I read from it. Now, if all the cores are running in parallel, like what on earth is that number going to be? Hi Raj, how you doing, dude? Just explaining how compute shaders kind of work, and hope your day's going well, by the way. So we have this bit of a short stream today, so I hope I'm glad you made it. So we have this thread, right, that runs on these multiple cores. Hello, Mabdo. How you doing, dude? Thank you for joining us. So we have a number that's added in each core, right? And each core runs random. Like, we have no idea which one runs first and which one runs last. It could be like this one, and then this one, and then this one, and then this one, and then this one. And let's just say this one runs, like, I don't know, 32... This is the 32nd, even. Call that runs, and we read from a number that's been added up over the 30-second calls. It's possible that this is 32, but it's also possible that it's, you know, some of these cores haven't finished writing our number, or so it could be like 31, it could be like 30, it could be 29, it could be 0, it could be literally anything, right? It could be anything between 0 and 31. Basically on how we're adding this to on the 32nd instance of our compute shader, meaning that we have a race condition where this is never always it could be 32 all the time until it isn't, right? Especially if I run this on someone else's computer. If I think that I can just add a number on a compute shader consistently without any effort to make sure there's no race conditions, it may work on my computer completely fine, and then all of a sudden it doesn't work on your computers, right? So I've got to be very careful with compute shaders here. So when we're actually trying to code this compute shader to do particle physics, we've got to make sure, when I say particle physics, it's nothing to do with actual physics, obviously, it's all to do with rendering. So yeah, we're not doing any like real particle simulations. We're just kind of trying to render as many tiny little bits on the screen as possible. We've got to be very careful that we don't have a race condition or we don't assume something is true when it isn't true, right? So right now, this is what we're going to be inspired by. We have a compute shader, actually. I've already written a compute shader that does cloth physics. So we're going to investigate today how I did that. The reason is, right, okay, so we just have a... I actually don't know how to do, it feels like it's such a long time ago since I wrote this compute shader, and it was such like a, you know, thing that just happened out of nowhere, that I don't remember the steps. I mean, this is fine. You can do for loops in compute shaders, but you just can't rely on the the number of instances, right? So yeah, we're gonna try and get something to work in our compute shader so we can add our particles, start to do physics, which will be good. Really advanced for me understanding what's going on here. But when I'm just studying OpenGL, my beloved Skater. Thank you, Angelica. Cutie, thank you for joining us. Yes, so we bit of a short stream today. Hello, Zephyrs. How you doing, dude? Thank you for joining us again. It's all good seeing you guys. So yeah, we're gonna wear compute shaders are tricky. I have to work on box 2T physics now. Oh, okay, so we're both working on physics today. Hey, there we go. So yeah, we need to have a system where we can actually do physics. And I have done physics before, so we're going to be inspired by a lot of things here. We're not going to do anything that interesting. We're not going to do spring force. But like I said, we just got to be aware that anything that we do in physics that we're writing values to, if it's local, it's fine, because that's per thread, right? If it's not local, if I'm assuming that this is going to be read by other threads, I've got to be extremely careful. I've got to use subgroup operations to do that. That's how you synchronize operations between threads, or atomic operations. So in our very, very basic compute shader, which basically just does one thing. Let's see. Where's our compute shader at? Okay, so particle compute shader. We are doing an atomic add. Now this guarantees that we are adding 1 each time to our what is it called? Compute shader, right? So the problem is, though, here's the problem I'm running into right now. If I run one more instance of this, it will create another draw call. And this is where I kind of like, I got a bit stressed yesterday, I'm not going to lie over this, but I'm in this tricky situation where I don't want every single particle to have its own draw call. That is bad. Because if I have a million draw calls to draw a million rectangles, that's going to slow the engine down considerably. If I'm able to, say, break up this into, I don't know, let's say if I have a million draw calls, I would probably have, I'd probably do maybe an instant render of maybe, I don't know, 50,000, and then 50,000 divided by a million, which would be what? So, excuse my terrible arithmetic. Right, so that'd be 20 draw calls, right? So that would be like a really good, that would be like, oh, 20 draw calls, trivial. And we're drawing a million things on the screen. The problem is, I don't know how to do that. So effectively, we need to basically come up with a system here that only writes to our command buffer, sorry, our draw call buffer, while also doing the physics. And now, here's the other thing we've got to worry about. We've also got to worry about the age of particles, because particles don't live forever. So I've got to also make sure that I don't try and draw too many particles in our draw call. Otherwise, we end up in a bad situation where I'm drawing things that don't exist. So yeah, there's a bit of a thing. So the first thing that we're going to do for like step one. This is going to be simplest. Move one particle around, right? So we're just going to do a simple with linear acceleration, right? The solution is another staging buffer, sure. Them. Hello. I'm sure that translation, you didn't mean to say them. Yo. Yeah, I have to turn off the translation. Yo, how you doing, dude? Oh yes, Konnichiwa, right. Mabdo. You automatically got translated to Konnichiwa, indeed. I don't know why Google Translate is automatically translating yo into them. That just makes no sense, but anyway. Thank you for joining us, by the way, guys. So we move one particle with linear physics, right? So I've done linear physics before. This isn't that it's hard at all. I just got to make sure that it can run in multiple instances of a compute shader without everything like blowing up, right? Right. So step 2, break up, like break up. So here's what I'm thinking. We could do this now, actually. Let's just give it a test. So if I run this for 2... so if... This is the tricky part. Because... into instances... I have to run this once. So... if I'm adding a value, I need to know the... not the max value, but like I need to be able to read a value between threads. Okay, so find out how to read a value between threads. This is our trickiest part, probably, because what I want to do, the idea here is I have like an if condition, right? So this is just pseudocode for a minute. Okay. So this isn't going to work. Okay, if I could actually type, that would be nice. Thank you. Ignore all the red squiggly lines, by the way. That's just my stupid extension, not understanding what buffer device address access is. So if I had this DCI and I said this is greater than, like, I don't know, or less than, let's just say 50k. Is that 50k? No, it's a 500k. Then I want to do this. I want to be like, all right. Then we reset the value, right? So then we go like, now. No. So this exceeds. It has to exceed. And then we have a second value. So that's the draw call count. Hang on, let me think. So this is like kind of how it should work. So we have a draw call count increaser here, but while this is running, we also have another atomic add, which is just keeping track of the instances. So this is the I think I can just have a thing out here. So uint 32. Sorry, uint instance count. Right. We set this to 0. And then what we want to do here, which is local, is hopefully this is static, but we'll see, is equal to that. Oops. So this atomic add keeps increasing, and then we say, I don't know, this, and then we kind of do, okay, equals 0, right? So that's kind of like the idea, but I don't know if that's even valid. No, unfortunately, yes, you'll... Mabdo, all your Japanese will be translated, assuming that you even type valid Japanese. So that's like the idea that I have, right? So instance count can't exceed a particular value. The problem is it also needs to happen for the first time, otherwise we don't have any draw calls at all. So this is kind of like something to work on later. Step 3 is then like make a good demo, right? For a... I don't know what to do here. I don't want to do rain marching for clouds. I feel like rain marching cloud. What I want to simulate is like dust, like space dust that just exists everywhere in the scene. For space dust, right? So the problem with that is we have to work with textures. So at the very least, we want one meaning. That we need a particle set concept, which means, okay, so how are we going to split up particles? Concept. We have, I'll just kind of write this out. No, I'll just explain it. So we have particles. It's hello, Michael. Thank you for joining us. I hope you're having a good day. So a particle set. What's a particle set? So individual particles have their own like stuff going on, but for an individual particle set, it's going to have its own simulation, right? So we can't have every particle in the scene doing exactly the same thing. Otherwise, we'll have one particle set for like whatever, 1 million particles, which would be a waste of time. What we really need is like, you know, like, I don't know, like 10,000 particles doing this. You know, you shoot a rock in the game and like, I don't know, 500 particles kind of show an explosion. We need like, oh, you crashed into an enemy, sparks flied out, kind of another thing, right? So we need like a lot of different like particles things going on, and so we need like sets. And step 4 would be occlusion view frustum calling. So do a view frustum call. So that's just going to add a layer of complexity on top of everything. But I think it's going to be worth it if we're going to try and push this with on the particles. So I have a feeling that we can do this. I don't think it's that difficult, but I need to do it. So this will be point versus view frustum, which I think is going to be quite simple. Collision. So we can do that in the shader instance, right? So we got all that. They move all the same direction. Could you create? Could create something cooler. Yeah, I mean, that's the idea right now. It's just like I need to be smart, and this is going to take some. I don't know how long this is going to take, but it's going to take a bit of time to get right. So, you know, this might be a reoccurring stream where we work on particles for a while, because we're going to need like. It's the part of the graphics that I have complete control over. The reason that I want to do nice particle effects is I don't necessarily have the ability to do something like nice models, right? Because I don't know how to do modeling, and if I were to pay for art, that's going to get very expensive, especially because I'm living off savings. So I got to be very careful here with my with what I end up doing with artists. I do want to work with artists for sure. That's something I am motivated to do. Because I feel like the last thing I want to do is use any AI at all, for a lot of mostly personal reasons. So I can get obviously free art off online, but you know, we'll see. This is like graphics I have complete control over, because particles are basically, you know, all up to the programmer. I'm sure there's like technical artists that do this type of thing, but you know, if it's a technical thing, then I have control over it. Anyway, so let's do. I'm kind of interested in doing step 2, because this is one that's bothering me the most at the moment. I feel like linear physics I can do at any point. This is step 3 needs 1 and 2 to do anything, and then the view frustum call is just like. Once I've got something working, and then obviously step 5 would be step 5 have multiple particle simulations. And if we have dust, we're gonna have to do something slightly different. That include particles that die. Right? So if you explode a rock in the game, we can't have that explosion particle existing forever now. Well, I mean, maybe we could. It'd be kind of interesting. But, you know, if you crash into something and there's like particles that come off because you crashed into something. I don't know if that would get inefficient or not, because we're going to have a giant buffer anyway. Okay, so... But in general, you typically have particles that disappear for efficiency. But yeah, who knows? Maybe we'll have a space game where none of the particles disappear and the game gets slower and slower and slower. I don't know. I don't know if that'll leave me slower, because we're going to have to carry around a buffer anyway with all the data in, and only make it disappear and reuse it later for something else. Anyway, so... This is the benefit of doing GPU-driven rendering, by the way. It's like, we can, like, you know, do stuff. Anyway, so what I'm interested in here is, can I do an atomic add on an operation like this and have it constantly add up? And... we need like a Boolean, right? Or something. Because I feel like this would be quite close. Yeah, let's. I want to see if I have. I need to use RenderDoc for this, because I need to make sure that I'm not getting multiple draw calls here. Because I need to do instant rendering with instant indirect draw calls, which is kind of like the hard part. So if you don't know what instancing is, for those who are newer to graphics programming, it's a very good technique. I'm using it all the time, actually. I won't actually run it, but my engine. I will run my engine, assuming this runs. I'll kind of show you what instant rendering is. Right. Okay. So you see these rocks. I'm doing this in one draw call. I'm going, draw all the rocks. I'm not going, draw this rock, then, okay, we've drawn that one, fantastic. Okay, GPU, then draw this one. I'm going, GPU, there is a buffer with all the positions in. Draw everything. And then for each thing that you've drawn, give it a position. That's instant rendering, where each one is an instance, and it has a position that we look into a buffer over, right? So what I'm trying to do here is an indirect instant draw call, which is like an indirect one is a little bit more complicated. Instead of saying on the CPU that we go, there's some code that says do the draw call. We create the draw call on a compute shader, and then we want to then we just do the instance thing that I just described. Hey Heisenberg. So what I'm going to do is throw this into RenderDoc. It looks like it's all good. Yeah, so it's a bit of a short stream today, Heisenberg. Hope you're having a great day, though. Hopefully this is all making sense for you guys. If anything's confusing, by the way, please feel free to ask me questions. I will try my best to answer them if you get stuck on something. Sent sparkles for two joules. Okay. I'll say, yeah, so true. Sent sparkle for 2. Oh, thank you. Thank you. You sent me a gift. That's really nice. Thank you. Oh, I see this is a gift thing. I've just turned this on. I'm not entirely sure what it does. But honestly, it's very much appreciated. Sent stars for 2 joules. Thank you. It's the first time I've ever seen that before, so that's very much appreciated. I'm not sure what it does, but there we go. Thank you. It's a very new thing. It's a Heisenberg, so it's very much appreciated, the support, and it's also appreciated, and all the reactions too. It's very nice. But anyone is here, you don't feel like you have to donate to me at all. I very much appreciate you all just watching, right? So I just want to provide value for you guys, and if I can do that by teaching you stuff or keeping you entertained while you do other things, then that's like good enough for me. But yes, thank you very much for the support here. So sent 2 stars for 2 joules. Yes, I'm the first one. It'll boost your channel reach. Oh, is that what it does? Okay, thank you. I see. Cool. Well, there we go. I'm glad you support. I'm glad you believe in the channel. Right, okay, so let's run RenderDoc. So, again, for those who don't know, who may be new, RenderDoc is a debugging tool that I highly recommend any graphics programmer learn how to use. It's honestly incredible. I'll show you how it works, right? So you capture a frame. You've probably seen me do this before if you've seen this, but I'm just making sure that everyone's on the same page here. And we can actually look at what the commands that were legit, John. And this, by the way, is not a this is not, let me say this, this is not Vulkan specific. You can do this in OpenGL. You'll get OpenGL commands instead. So it's highly recommended if any of you are doing graphics right now, you learn how this tool works, because this is going to be incredibly insightful for oh, why is nothing on the screen? Why is it all black? Okay, load it in RenderDoc and you'll see, right, okay, so this draw call is covering the whole screen in black, right? That actually happened to me. And I was only able to see that. I was like rendering everything fine, and then I was drawing a rectangle that was completely black over the whole screen. So, stuff like that you'll be able to see, because you can step through in texture view, for example. You can see it like slowly building up the scene, and you can investigate what the buffers are for individual things, and it's really useful. And this is our indirect draw calls. So here is what I'm trying to investigate here. I want to make sure this stays at 1. We're going to try and make this stay at 1. This is the challenge. Can we make this stay at 1? So this is our indirect draw call. We want this to stay at 1, but it have multiple instances. And yeah, we shall see if I can do that. We will have to then build a buffer that tracks the position of things, which is fine. We've done that before, which is what this is. This is actually giving us the data for that instance. But yes, okay, so now hopefully we're on the same page, and yeah, highly recommend anyone if you don't know, render dock is absolutely goated. You can even use it if you want, if you if you're really interested. You can load in a game from Steam that you're interested in and just like push it through render dock and see what it's doing. This is how like other graphics engineers get like understand what other people are doing, right? So they'll be like, oh, okay, so he's doing this, 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 and this. It's like how Threat Interactive, for example, understands how how the game works. Anyway, yeah, so there we go. Yeah, thank you guys. Right, so let's beat this up a bit. Or you're wondering where? I'm wondering where is your game loop? Yeah, sure. It's in main, and I have two loops. I have the main menu loop and the game loop. And the main game loop is literally a bit of a hodgepodge. It has all three things in. It has the handle key presses, update the physics, or update the world, really. It's not really always physics, but yes, most of the time it's update the world. We have deleting things in here as well. And yeah, then it's render. It's all like one big thing. Maybe I should break it up. I haven't really decided yet. Anyway, so let's try and get this working. So I need to think right now, and we need at least one draw call. And if I say this is, it can only make a draw call once this has finished filling up. We need a way to, basically, let's just say what we have, 26,000 particles on the screen. This is less than 50k, right? And the problem, yeah, instance count should be here. The problem with that is, we need kind of like, we need a way to know. Okay, so we have two things here. We have we need to know when something has when we are on the last thread, like last instance. I don't know if we can know this, but we can see. And we also need to know when we are on the first instance. So the first and last instance of this need to work differently. When we need to know when we are, there we go. That's actually we need to know when we're on the last first. And okay, so these are the first. This is the, come on, let me click. What is what is happening? Visual Studios has crashed. What is going on? I was like crashed over typing a comment. What the hell was that? Oh my goodness. What a disaster. Who coded this thing? Jeez. It deleted my comments. What the heck? Bruh. You can't handle comments? Maybe it is time to move to Neovim. Okay, so when I'm just gonna say this. When are we on the first instance? When are, these are the questions. When are we on the last instance? So, oh. No, this is still not right. No. This is fine. We actually don't need to know the first instance. We need to know the last instance, because then we absolutely have to make a draw call, regardless of the instance count, right? Let's just say that we are on. We only have 200 particles in the scene. We need to know. Okay, we don't have enough to fill up a full draw call of instances, but we're on the last instance. Make one anyway, right? Otherwise, we have nothing to render. So that's the thing. Okay, so we need to know that for a compute shader. So let's do a quick Google search on this particular idea. I think this might be quite straightforward, but because I think it might be the atomics, sorry, the intrinsics that we have access to. Right, so when do you know you are on the last instance of a compute shader? So, oops, compute shader. So that's the question I've got. By checking the thread ID, I guess I can use AI for this and kind of ignore it after it's. Okay, so what are we doing here? What are you telling me, sir? Am I taking compute shaders? Okay, so so this is the first task. If we can solve this today, I'm pretty newbie when it comes to compute shaders because I don't really write them very often. Okay, so I don't think it matters that he's using Unity here. I think we might be able to figure this out. I think if I look actually at the SV instance count. This is what I'm going to look at for compute shaders. No, I need the GLSL compute shader. So what I'm trying to find is the intrinsics, right? These guys, right? So the number of work groups. I think we might be able to access something in here that tells us like we're on the. This is the total number of things that we're doing, right? Okay, so and then we can compare a val. We can say, oh, we're at the end. And then we can absolutely guarantee that we're going to run something, right? That's the goal anyway. So, because we need to know what we're on, and I think we have something here that might be useful. Okay, so GL. I'm going to read this out loud. GL num work group. This variable contains the number of work groups passed to the dispatch function. Now, I don't think that's what we want. That would be how many groups of threads are we running at times? So like how many warps or how many wavefronts, which is not quite what we need. So look, but that's kind of like what we're after there, which is kind of nice, like kind of something like that. Let me just plug the laptop in. Yeah, I feel like I finally got like good night's sleep. Yesterday I did not sleep at all. Anyway, work. GL work group ID. This is the current work group for this shader invocation. Okay, so that's okay. That's not what we need. Each XY component is half. Will be on the half open range. Yeah, that sounds good. I stayed up till 12. I'm naughty. Yeah, I couldn't do that very often. I sometimes do, and I regret it every single time. GL local invocation ID. This is the current invocation of the shader within the work group. Okay, so that's within a work group. Each of the XY components will be... Okay, yeah, that's fine. So that's almost what we need. The GL global invocation ID. This value identifies the particular invocation of the compute shader among all invocations of the compute shader dispatch call. It's shorthand for the maths. Okay, fantastic. So that would at least tell us the number that we're on. So we might be able to do some logic on that. But I don't know which one's last still. GL local invocation index. This is a 1D version of the local invocation ID. Okay, it identifies this invocation index within the work group. It is shorthand for invocation index. It is shorthand for this. Oh, okay, so that is across each. Oh, okay, so that's actually quite useful. So it looks like, as far as I'm aware, this is a 3D version and this is the 1D version. Because the maths looks like it's identical. So it's work group size. So I think work group size is... Actually, don't really understand. Okay. Yeah, lol, same. Yeah, it's pretty... Sometimes you just, like, don't want to go to sleep, and it's not... I feel like it's a lie that you tell yourself you don't want to go to sleep, because tomorrow you're going to hate yourself for it. Okay, so global variables. Okay, fantastic. That needs to be shared. That's exactly what we need. So that, yes, I was aware that we needed to do something special here. Can be declared shared. Variables. Okay, so in invocation, you cannot declare opaque types, which are what? Opaque types represent external objects. I'm sure that's not an opaque type, but right, okay, so so what we need to know is I think it's local though, unfortunately. Global invocation ID. If we make this a one-dimensional array, is that bad or good? I don't know. If I look at my old compute shader that does physics, what did I do? What was my... Okay, so I, for some reason, decided to make it 111. Which kind of defeats the point, I guess, but anyway. So I'm going to make it one-dimensional because that's going to be easier to deal with at the moment. I don't know if that's optimal. Anyway, so let's keep on going. So what would be the... How do I know it's the last guy? Is this in here in the... No, that's not what I want. What was it on? Do you have this here? Nope. That was my Windows noise. Oh, it's HLSL syntax. HL SL. Alright. Jeez, typed it in wrong. HLSL, right. So what is this version? You're not okay, whatever. We'll just deal with it. So we have an increasing value, but we don't know the last invocation ID. What would be the last one? So we have the global here. I mean, we can probably work it out, maybe. So this is the number. Yeah, we can probably do the maths here. This variable contains the number of work groups passed to the dispatch function. So that's the number of work groups. This tells us that, okay, so we're not going to use these. The number of work groups. The number of threads per work group, I don't know. I think that might literally be... So if we have number of work groups plus... So that is the... Yeah, this is fine. This is always going to increase by 1 for each invocation, which is chill. So that means this works because if we have one instance, then it's cool. What I'm thinking anyway is number of work groups. Is this a does this have dimensionality to it? Plus, I assume number of threads in that number of work groups, right? Is this, and that means that we have last index. Okay, so it's a vec3. So if we're using one dimension, then it should be that last index. Meaning that if... Oh, no, it's not add, multiply. So I assume that we have number of work groups, which is the number of, I believe, as far as I'm aware, this is a work group, this is a work group, this is a work group. Number of actual invocations is how many of these, how many of these fellas do we have actually, like, what are we on? Like, are we on 7, 2, 7, 9, whatever, you know? So what I'm going to say is if, or, draw index, which is this, is equal, whoops, is equal to the last index, right? So in theory, as far as I'm aware, we are adding to this fella over and over again, atomically. Do I need to atomically set that as well? Hang on. Let's just check out the atomic adds for a minute. Yeah, I think we should be good, but I don't know. So now we should have the same stuff again, exactly the same, nothing changed, except if I'm understanding what this means, and I understand that this 64, I don't know, can I use this kind of like that? No. Let's see, in here, no. Oh, hang on, this is kind of useful. The local, so it's telling me what this is. The local size of a compute shader is defined within the shader using the special layout as input. By default, the local size is 1. So if you only want to do 1D or 2D work groups, so if you want a 1D or 2D work group space, you can specify the X or the XY components. They must be an integral, a constant expression of a value greater than 0. Makes sense. The values must abide by the limitations imposed below. If they do not, a compiler or linker error will occur. So the local size is available to the shader as a compile time constant. So you don't need to define one yourself. So it looks like, as far as I'm aware, workgroup size is this. But we need to know the work groups, like how many work groups we have, which isn't the same. Let me get rid of that translation. Ayo, bot red gaming. How you doing, dude? Hopefully you're having a good morning or afternoon or evening, I guess, as well. Or wherever you are. Okay. Okay. Yes. So, what are you doing today? We are trying to get a particle physics to work. So we're just doing some. Oops. We're doing some linear particle physics stuff, which is cool. But I want to do the draw calls first. So it looks like I'm just trying to learn compute shaders better, so I can actually do this. So yeah, this is going to be 64 every single time. Unfortunately, that doesn't tell us how many threads we have total. So I'm trying to work out the maths for working out how many invocations of something that we have per frame, per dispatch of a compute shader. Sorry, not per frame. So I'm just reading over the documentation, because we have an indirect draw call, right? And I want to use instance rendering still, because particles are extremely cheap to render if you can do instances, right? So the idea anyway is to have only like one draw call per set amount of instances. So if I set the instances to a regular value, and then I make, because the last thing I want is to have a draw call every particle, right? The problem with that is it can really slow things down. So yeah, we're trying to make it so that we only have one draw call for like 10,000, 20,000, 30,000 instances. But now we run into a problem where, let's just say that I set the draw call count instance count to 20,000, right? So we have I don't know, a 42,612, right? We still need to draw those 2,612, right, particles. We can't just say that for each, we can only draw them if it fills up the instance count completely. So we're trying to figure out how to make sure that we can draw that extra section by making sure that when we're on the last thread that we do also generate a draw call of a compute shader, which is, I don't know how to do that, so we're trying to work out that. So if that's a little confusing, let me know and I can explain bits. Like if you got lost on a particular point, let me know. But in short, we're working on particles. If that was a bit too complicated and you don't know what I'm talking about. Because we got GPU-driven rendering working yesterday for particles, which is lovely. And that is just generating indirect draw calls on compute shaders. I thought you wouldn't stream on Sundays. Yes, sometimes I sneak one in. But again, these are going to be a short stream, so it's not going to be... Thank you for joining us, by the way, bot. So yes, I'm not going to be streaming for 8 hours, 9 hours today. Certainly not. So yeah, let's dive back in. How do I know though? So this is 64. How many work groups? It tells us the work group ID, which is just, you know, how many invocations? So it's the 1D version of the... So what I'm trying to work out here is based on... So we have global invocations. And so the work group size... I think what we might have to do here is literally... this value is unique identifier that just for a particular invocation. No, that's just not right. Work group size... Wait, where's this? This is not defined anywhere. Number of work groups... Hang on, wait a minute. Well, oh, work group size is different from number of work groups. What? Okay, a completely different thing here. So you have work group size, hang on. And we have number of work groups. Is this the answer? Number of work group size. Is that 64 times by the number of work groups? What is the difference between these values? That might be the last index. Yeah, what is that? It hasn't told me. In a compute shader, GL number of work groups contains the total number of work groups that will be executed for a compute shader. The components of the... Okay, so what is a work group in a compute shader? So let's just go back to basics, right? Replace coffee with milk. Game loop said, I need a holiday. Compute shader work groups, yeah, totally. Compute shader work groups. Hopefully you don't get too tired. Yeah, what is a work group? So let's just see definition. Work group. Okay, group. Hopefully there's a definition somewhere, because that would be really nice to make sure that I'm not making a mistake here. Okay, cool. The compute space. The space that the compute shader operates within is abstract. There is the concept of a work group. This is the smallest amount of compute operations that the user can execute. Okay, or to put it another way, the user can execute some number of work groups. The number of work groups that a compute operation is executed. Yeah, there we go. Game loop isn't born exactly. One day, maybe. One day. The number of work groups that a compute operation is executed with is defined by the user when they invocate this compute operation. Ah, okay, so the space... Okay, let me think. I just had a thought. Alright, based on that, I think I might be making a conceptual misunderstanding here. Okay, VK dispatch. Whoops, I just want to search for that, thank you. VK dispatch. Where's the compute shader? Alright, I'll just find it myself. There it is. Okay, command dispatch. Okay, so now if a okay. Draw count. If I set the draw count to 2 and I set this to I don't know 10,000 for that, what's the value that comes out of this? Let me just see. So, sorry this is maybe a bit mathy, but I think I'm making a conceptual misunderstanding here. We have a bad shared can only be... Oh, sure. I didn't know that. That's completely chill. I assume it has to be assigned to that. Zero? I don't know what's going on here. Alright, so we'll just get rid of this for a minute. This is going to run, I think, every single thread, which is annoying. But I kind of just want to get this to run again. How? Multiverse. Hi, Rock. How you doing, dude? Rock to 11. Atomic add. Right. Okay, so I think this is just not going to work for a minute. I kind of don't care at the moment for this, so I'm just going to get rid of it. We can always add that back in. Can we just get past this? I don't... Oh, yeah. Finally. Why is there loads of warnings? 2D data does not exist. Yes. Wait, why do you think you exist still? Hang on. Let's go to our compute shader real quick. Wait, what is going on? That is a strange error warning. There's so much energy indeed. Why do we get this warning? This makes no sense. Yeah, stop including a value that it really doesn't exist. 2D data didn't ever work, so I removed it. Reload. Okay, cool. Hopefully that gets rid of that weird warning. Give it a quick compile. Okay, cool. So what I'm interested in here is to see what the hell this value comes out to be. Did you know that researchers just freezed sodium gas and the light inside slowed? Wow. to 38 miles per hour. Jeez, that's some intense attenuation. One draw call. 10,000 of these fellas. One thread. Yeah, I need to know how to use this function properly. This is confusing. Like, what is a thread? What is a thread? What do these values mean, right? I think I might have looked this up just before. Alright, so work group counts. So its command buffer is the number of local work groups. Okay, to dispatch in the X dimension. When the command is executed, consists of you know what I could do? I've got an idea. Hear me out, hear me out. We could abuse this a bit. Instead of that, we do this. Here's what I'm thinking, right? Number of instances here. Number of draw calls here. So we actually do this in 2 dimensions. So this is a 2-dimensional grid, right? And what we're going to do... Hi. Hello, sir. Great stream. What is the current progress of your engine? We are currently... thank you for joining us, by the way. Sorry, I was a bit locked in just before. We are in the midst of trying to work with compute shaders to build up our draw calls. 684 lines, yes. What, this thing? This is sus. It's fine. So let me show you what the game looks like, actually, because I feel like it's worth showing you that. I do have it here, just currently. So we have a terrible menu. And we have a little space game. This is the player. I have the no clip camera on. Everything around it here. We have debug geometry for the collision geometry. That just tells us what we can collide into. Of course, at the moment we have no collision, so we can go inside stuff. But if I was to be the player, if I turn off the debug geometry, it makes like a bit more sense what's going on. We have 2 basic lights in the moment, and we are trying to get this fella here to. The goal is at this moment in time to try and get this to be 1 million. Right, we're trying to get 1 million of these little particles on the screen. We have billboards working, so yes, we're going to try and spam as many of these on the screen as possible, and this will be used for different effects through to make the things look nice graphically. So yeah, that's what we're up to. Yeah, thanks guys. Don't use a unsigned integer for counts. It can be a big issue. That's fine. I just know that that it can never be negative. Yes, there is an interview of me and Kukatu's YouTube channel if you're interested. It was very nice of him to give me a lovely interview. He's a fellow friend, game developer guy. He gave me an interview when I had I think 300 subscribers or something. So he's a real cool guy. If you do want to know more about me, I was employed at the time. That's the only difference right now. When that interview was posted. And I would say the only addendum I would give to that interview is that at the time I said I did enjoy my work, but I was struggling with some things, right? When it came to the CAD industry. So although I make it out to be good, because I was kind of nervous my employer might watch. I can say it I can say a bit more truthfully. There were a lot of things I wasn't happy with while I was employed at the time. Almost at 3.5k. It's well, we'll see. We'll see if that happens. It's one of these things. I'm grateful for anything like I keep saying this all the time, but I was surprised I got 40 subscribers. So it's I'm very grateful for you guys. You know, the fact that you wanna hang out with us is very nice. So if I do, I don't know, say 2 draw calls, then here's what I'm thinking, right? We do a draw call per, so we do this, right? Work group size. Wait, sorry, work group ID I think we need. If I go to here. Yeah, we had 3.1. Yeah, it's growing very fast. I think it's that video. I think people really resonated with that "How to Become an Expert" video. It's really nice, actually. It's still a massive shock to my system that that video did as well as it did relative to my other videos. View family ignored, not sus at all. There we go. Well, I can explain that briefly if you're interested, but it's so draw call counts. Ah, come on. Is equal to that, right? And data index. I think I need to do this per Y as well, if we're doing 2 dimensions. So here's my theory, right? Instead of doing this at all, we kind of do something a bit different. For each time that we keep track. So I'm going to try and do this with 2 draw calls and 1 instance, I think. So what I'm going to do is we're going to try and make 2 draw calls, and so we're going to make 2 particles. And I might kind of change this a little bit in a minute. But I'm going to throw this into render doc so we can see what's going on a bit. Alright, so yeah, we're going to try and change this into a 2-dimensional compute shader instance. I don't really know how to say that. Is that correct? This is a 2-dimensional compute shader. So we're going to have 1 particle per 1 instance of a particle per each draw call. If I can pull that off, then we're basically done. But the downside is I don't know what the maths is. As far as I'm aware, if we have the global ID X and Y multiplied together, we'll have a unique ID. So let me just make a grid real quick in Paint. I don't think this is going to take that long. So if I have this, and then I have it, I'm just going to make the simplest grid ever. So this, and these are each threads that are going to run, and I say that in X, so this is 0, 1, and this is obviously 0, 1, and I want to get to here, and I say, okay, so this is the X, and Y. This might be overkill. You might be like, duh, this is obviously how it works. How do I get to here? So if we go 0, and we've got X and Y here, so how do I know that we're on this? I think I want the index value. So this will be 1, 1, right? Yeah, that's not how it works, is it? But if I wanted to make it 1-dimensional, I think it is a multiplication. I want to change this into a 1-dimensional operation. So if I... No, that doesn't work. I would need to add them together? Yeah, I think I need to add them actually, not multiply them. So if I have index, if X is 1 and Y is 0, add that together, I get 1. But if I get this plus that, that's also equal to 1. So that doesn't make sense. Ah, right, that's it, yes. Oh, it's this escape point. Right, so let's try that. So we're at 0. We'll do. We want to get to here, so multiply these together plus x. So I think this is a solved problem. I just can't remember how to do it. That would give us. This would make it so this would be 1, obviously, plus 1. And that would be 2. And if we index count from here, so let's just pretend we have a one-dimensional matrix. Let's just make this again. This is the 1D version. This would be 4. So this is the sorry, that's way too small. So that would be. This would be. Hang on. So this would be 0, 1, 2, 3. Maybe we need to add y as well. All right. We need to be able to get to 3 if both x and y are 1. Is it really just xy plus x? Is that right? I need to Google this. This is a solved problem. I just can't remember what to do. How do you turn 2-dimensional data, 2D data, into a 1D data? Because this is how you do. Yeah, this is what I need. Okay, this is flatten is completely useless. Yeah, but how do you do that? Mathematically speaking, bro, that's completely useless. I think there is something like that. What is the hang on, let me look at is that it? Is it? Ugh, I'm getting confused. All right, we'll just do that. We'll give it a shot. Look, I'm not entirely sure what you said there, bot. I assume that was a message sent to the wrong person. Look, Virats. Yeah, I'm not sure. I've literally, it's like... Yeah, okay, so that's hopefully one-dimensional, because we've got to change it to one-dimensional data here for this index. We say draw count is equal to that. And... Hmm. Uh, 51. Oh yeah, they've been GL for 8. It's GLSL more than OpenGL. What does GLSL stand for? Is it OpenGL shader language? What does GLSL stand for? Yeah, the OpenGL shader language. Yeah, that's exactly what it means. Yep. I have to go. 2 words, H and W. This is Bart signing off. Well, I'll see you soon. Thank you for joining us. Okay, so let me think. Finally, I deserve number 1. There you go. Yes, number 1 fan. I think that's what it is, isn't it? Yeah, top fans. Yeah. No, I don't really. I don't think referring to you as fans is. I don't know. I've never liked the word fan. Yeah. Okay. So this is the same idea. Yeah. This is a one-dimensional. Yeah. Okay. So I think we're on the right path here. We're almost done. So Number of draw calls. With our draw call count, we set this to 0. Don't we send this in? This is the thing I'm confused by. I don't understand why we have like a value that's sent in, then we increment over that value, and then we increment by 1. If we wanted to just... This is the thing I think I'm getting confused by. I have a feeling that I'm kind of doing stuff that I shouldn't be doing based on... Yeah, top chatters, there we go. I'll say that. That's yeah, YouTube says fan, I'll say chatters. Alright, so let's think about this again. Sorry, compute ID. Top yappers, there we go, yeah. So it's going to our compute shader. Yeah, I knew this would be a bit of a research task. Hopefully you're here for it, guys. Alright, we'll change the music. I think we've heard this one before. Okay. It's the most intense music any video game's ever had. Let me think about this. So, right, we don't have Y anymore. We're just going to use a one-dimensional array. We don't have this anymore. Let's get rid of that. But I have a feeling that this is... No, we are increasing this... Okay, no, that I was right first time. Sorry. I was kind of right. The reason I'm kind of right is... I'm certainly British, but no, yeah. Most people are like all over the place. It's kind of cool, actually. Alright, so... as far as I'm aware, anyway. So, yes, I was right first time. Okay, so the reason is we flatten the 2D array into 1D. Yeah, this is like a this is by the way, this is like yeah, I think last stream I was talking about how leak code is often not very good. This is exactly when leak code is very good. If you've done this is the type of problem that leak code is very good at helping you solve. Not that, I don't want to spin off into is leak code good or bad, but I think I didn't really have a good example of like what's the point of studying leak code, and stuff like this is like how do I flatten a 2D array into a 1D array is a very leak codey like question. Anyway, yes, we don't need this. What we do need is to increment this by 1 each time this increases. So if we are on 1, we have draw count. No, this will just always increase by 1. This is still not a complete thing. We need to make 2 of these, and that's it. How do we do this? I've been doing graphics programming for 30 years and I've never heard of such referred to as leak code. Haha. Yeah, there we go. Wow. Didn't realize we had such an expert. Oh, I can you know what? I've just looked at your profile picture. That's a big giveaway. If I actually saw your profile picture there, Rock. You have the Amiga bouncing ball demo as like part of your profile picture. I'm glad you're here, dude. There we go. 30 years. I can definitely guarantee the yes. Only the old heads know that one. I've never done leak code. It sounds silly. And also, damn, you're all unks. Yeah, pretty much. There we go. Okay, so now I need to know what. Oh, this is super easy. Because we can just get the global. If I go back to this, hang on. What work group are we on? Work group ID. Hell yeah. This is it. This is it. This is it. This is how we solve it. Why? I still haven't solved it. Dang it. But we're close. Oh, you know this one? Yeah, I think it's Foregone Destruction. It's an Unreal Engine 1999. Unreal Tournament, even. Yeah, Foregone Destruction. Tracking music. Good old tracking music. Ba-na-na-na-na. Good old drum and bass. Well, it's tracking music plus it's also drum and bass, yeah. So it's the number of work groups. So that's the total size. Hello, Ethan Hunt. Doing Mission Impossible. Yeah, let's do it. Right. Let me think. Oh my goodness. Thanks for the sent gift. Spent a star for 2 jewels. Thank you very much. I've turned this on literally just before the stream. YouTube was saying that I can turn it on. I didn't know what it meant. But there we go. Now I've got lots of. I've got a star. I've got a star. Someone sent me a star earlier today. I think Heisenberg did. So I've got a couple of stars now. Thank you for the support. I'm not entirely sure what they do, but there we go. It's very much appreciated. Oh, there we go. Sent a chili for 6 jewels. There we go. How do I do that? I have no clue how it works. So, wow, there we go. 10 jewels. Thank you. Very much appreciated, guys. It's I literally don't know what they are, what it means. But I'm sure it's good. I'm sure it's a positive thing. So thank you for supporting the stream. Yeah, I don't know how you get jewels. I don't know anything about this. Are you paying dues for this? All right. Chill. Maybe with the jewels, perhaps. I don't know. Yeah, chill. Anyway. Okay, so let's get back to this. Ugh, I'm losing. I feel like I need another cup of tea today. Yesterday was so hot. I was a bit overwhelmed yesterday. I was honestly just lying in a field, thinking about programming. Because it was too hot. No, I don't think I did. So what we need here is I believe the So that's the total instances in a 1D. This is the total work groups. And if I wanted to know the total, that's the number of work groups. If I have the total work groups, which is pretty straightforward to find, which is just this number. And that is in, let me just grab open the documentation again. We have, oops, multiply this to X maybe? So, wait, work group size, which is the 2, number of work groups. What is, I still don't understand the difference between these two. They seem the same number. Work group size versus number of work groups. But literally, what's the difference? This is all very new to me, so... work group size, number of work groups contain the number of yeah, let's just check something real quick. Just gonna make sure everything's good on the other laptop. I think I just need to okay. No, okay. Yeah, I think we're all good. Yep. Yeah, I just wanted to make sure the back. I'm just making sure the stream's still good and making sure we're still all good. Moving along. Okay. Anyway. Okay. So the components of num work groups are equal to. Yeah, it just seems like. So so these are the things passed into the parameters. I see. Oh, that's really useful. That's really useful, actually. So that's the difference. So it's not this number. It's a different number. That's actually really useful to know. So that's what we end up passing in. So that means that that's the... So if I pass in 2, that will always be 2. And if I pass in this is the instance count. So this is uint. Instance. So total instance count. So this should be 1. It is an annoyance which has taken me. What is a compute shader? It's an annoyance which is taken over from discrete kernels. Yeah, I see. It's yeah. I'm more familiar with that, but I'm sure it's an annoyance. So a compute shader is so we have the graphics pipeline, right? The traditional graphics pipeline goes. I'm gonna do a very, very simplified version. Let's see if I'll explain it a bit better. If I have a... Where's Critter gone? I'm going to open up Critter real quick. Can you hold on while that just loads? I'll explain it a little easier. What a compute shader is and like why it's what we're trying to do here. But effectively, very summed up, it's a generic shader, right? Super generic. Allows us to do GPGPU. Alternative to something like OpenCL and CUDA. That's basically it. if I open up this, though, we have a rectangle, red, make it smaller. So we have the traditional, oops, okay, that's way too small. So we have the traditional graphics pipeline that kind of goes like this. And if I go back to brush, so this is the vertex shader. Vertex shader and the fragment shader. This is very simplified. And then the output kind of goes like this, right? Like these are dependent on each other. We have to finish the vertex shader first before the fragment shader. The compute shader, there's other steps in this, but I won't go into it. You know, if I change the color completely to demonstrate this, is like its own thing, right? It like kind of runs whenever it wants to, and it's not connected to anything. So, yeah, yeah, this can run at any point. It's not connected to the graphics pipeline in any way, unless I tell it to be connected at some particular point. But it does. It's known as GPU. It's an answer to the question back in the day. This is quite interesting. I kind of find it interesting. Anyway, people used to do compute shader work within the fragment shader, which is kind of strange back in the day. So what they would do is they would pass a quad that would or a, if you imagine this is the screen, right, this vertex shader, they would sometimes they would pass a quad that would just be like two triangles like this, right, over to the fragment shader. Or if they were even better, if they were a bit smarter, they would pass one triangle that would fit in the whole vertex shader like this. And what they would do is they would treat pixels as like generic data, and they would do some kind of operation on that. So they introduced basically that idea for a compute shader, right? Now, you may think, like, what was wrong with doing the original approach? Well, having the vertex shader run first so we can do fragment shader work is wasted effort. So that's why the compute shader was invented, to avoid this kind of like forced use of the fragment shader, because there's the vertex shader and then there's like the rasterizer. Like, we don't need the rasterizer. If you're a physicist doing some like compute work, you don't need to worry about the rasterizer. You don't have to worry about the pre and post rasterization steps for depth tests. You don't have to worry about the vertex shader doing like transforming vertices that runs 3 or 6 vertices depending on how many triangles you send up to do a full screen pass. All you want to do is just take the pixel data and then do something with the pixel data. We're basically doing that, but with a generic compute shader instead. So yeah, that's what it is. Pressed F for 10 joules. There we go. Thank you. I wrote DX a D3 D12 MIP map compute shader for Apple for Adobe Photoshop a few years ago. Wow, that's really cool. That's actually really badass. It creates a high quality MIP map for canvas zooming. So pre-computing things in a general way to think about rather than frame-based rendering. Yeah, there we go. So that's a fantastic example of like, we don't want to have to worry about frames. We don't have to do the rasterizer, right? Rock 211 has done some, a really cool direct 3 min map thing, so you can zoom in, I assume, like almost infinitely on a canvas, or zoom out as well, and it doesn't like distort everything, because we have a MIP chain of textures, which you would need to do something like that, right? Frame independently. So yeah, that's how it works. And thank you for the 10 joules, or a press F. I'm not sure what I should be thanking for, the joules or the press F thing. I still don't know what these do, but there we are. Yeah, it's all appreciated though. Thank you for supporting the stream. Anyway, so and this is why we have to deal with and compute shaders are especially a bit weird. You have to be careful with dimensionality to your compute work. What does that mean, right? Well, some operations work better in 1D, where all the threads kind of, I don't really understand this very well, but yeah, you can have like 3-dimensional compute work, 2-dimensional compute work, and 1-dimensional compute work, which has nothing to do with the actual dimensions of 3D graphics or 2D graphics or anything like that. It's just some type of general compute work works better in 3D, 2D, or 1D. Press F for respect. Thank you. Yes. There we go. I just don't know if I should say thanks for the press F for respect. Or thanks for the 10 joules. And also thanks for the reactions, guys. But anyway, it's neither here nor there. It's yes, thank you all for supporting the stream. It's all very nice. Anyway, so we have so what I'm trying to do anyway is I'm going to have this idea where we have one dimension set up for the instances for the particle and another dimension set up for the draw calls themselves. I don't know how that's going to work for our physics, but we'll see. We'll see how this works. This might be a bad idea. GPU is basically a big SIMD, single instruction multiple data machine, and such concepts such as GPU threads and 1D and 2D and 3D are just an abstraction from that. Yeah. Isn't it single data multiple thread? Or it could be... What's the opposite? I thought GPU was a bit different from SIMD. It's multiple threads, single data. I can't remember. SIMD is a concept for it's like an optimization thing that your compiler will do, and often you can write yourself. And it stands for single instruction, which would be like one, like one operation, for example, an add operation, but with multiple data. So you can imagine a SIMD add would be, for example, the simplest one in the world that you have is a SIMD add that would take in 4 adds. It's like the single instruction would be add, and it would add 4 numbers together at the same time. Thanks for the gifts again. There we go. Anyway, let's lock in a bit. But I think, as far as I'm aware, the GPU is something slightly different from single instruction. I think it's like multiple instruction, multiple data or something. It's something else. I can't remember off the top of my head. It's this. I keep forgetting what this acronym is. There's another acronym out there that means like the opposite. It's like multiple instruction, single data or something. Anyway, but yeah, let's not get too distracted here. There you go. What Rock is saying there is a type of SIMD is AVX2. But yes, that's it. MD. Yeah, I think that's it. I think that's what it is. I might be tripping. MD. Is that a thing? Yeah, multiple instructions, multiple data. I think that's what a GPU is doing. Right? Okay, that's completely useless. Yep. What is this? What am I on? I want to see... Yeah, I think we're doing this. I think this is it. Yeah, I think MD. But anyway, there we go. Single instruction, multiple threads. Yeah, there's multiple acronyms that mean this, like, different things. But SIMD is definitely the most in. If you guys are like learning computers, I would say and you want to learn any of this that we're talking about in chat, SIMD is by far the most important. It's by a mile the most useful. Yeah, no sim. Yeah, there's no sim SIMT. Yeah, that makes sense. I don't think. Yeah, that seems a bit. Anyway, I think this has gone on long enough. Let's try and work this out. So we have total instance count per draw call. I want to do something per. How do I do something per group? Is it a subgroup operation? Let's look up subgroup operations. GLSL actually. Subgroup tutorial, fine. How many invocations are in a single subgroup? I don't know if I need to turn them on. Okay, so subgroups are an important new feature in Vulkan 1.1. They are a highly efficient way of sharing and a multiplication of data between tasks running in parallel. Hi Bonked, by the way. I don't think I welcomed you in the chat. Thank you for joining us. Yeah, each thread has its own PC. Yes, has its own program counter, and takes branches. Okay, each wave. Yep. In pure SIMD, you can't do that. You need to manually mask off each lane. Yep. With masks, I don't know SIMD very well, but I have done some masking in the past, and it was complicated. But things still execute every instruction in a program. Single instruction multiple thread is basically a more flexible and dynamic version of SIMD. Oh, okay, thank you. Right, that explains things very well. Thank you. That was nice of you to do, Bonked YT. Also, most an unrelated thing, not stalling CPU cores for long dependency change. Yes. Yes, we have a... See, these guys in chat know a lot. So I'll put it that way. You guys are... Yeah, the stuff you're talking about, I basically learned, like, maybe in Casey's Moratori's course, and I haven't done that very recently. Yeah, breaking up dependency change, how to use SIMD, masking off things. Yeah, it's very cool. Anyway, in this tutorial, we'll cover some new subgroup functionality. Modern heterogeneous hardware like GPUs gain performance by parallel hardware and exposing parallel pipeline models to targets this hardware. When a user wants to run n parallel tasks for their algorithm, a GPU would divide this n tasks workload between the compute units of each. Yes. Yeah, okay, so basically we have the each compute unit of the GPU is capable of running one or more of these parallel tasks concurrently. Cool. In Vulkan we refer to... I might have to make notes on this actually. In Vulkan we refer to this data that runs on a single compute as a local work group. Okay, it's just a local work group. And an individual parallel tasks as an invocation. Right, fantastic. Vulkan 1.0 exposes a method to share data between invocations in local workgroups via shared memory, which is exposed only in compute shaders. Shared memory allows for invocations within a local workgroup to share data via memory that is faster to access than reading and writing to a buffer. a buffer memory, providing a mechanism to share data in a performance-sensitive context. Vulkan 1.1 goes further, introduces the mechanism of shared data between invocations that run in parallel on a single compute unit. These concurrent running invocations are named subgroups. Okay. This subgroup allows for sharing of data between a smaller subset of invocations than workgroup. Okay, so then local workgroups, but at a significant higher performance. Oh, cool. While shared memory is only available in compute shaders via shared data, subgroup operations are allowed in all shader stages. Okay. Via optional supported state. Okay. So you got to be careful with this. This is kind of getting in the weeds. But anyway, so it looks like something we need to turn on. Yeah, I think this is something we need to turn on. I have a feeling that basically everyone has this extension. Let's just check. I can't imagine it's like a I have to worry about this. You might know the term MST2 symmetric multi-threading, aka hyperthreading. The low-level stuff is where the real fun begins, indeed. That is, I'm not as familiar with, actually, admittedly. But there we go. I knew of hyperthreading, but I didn't know about why, like what it was called, like officially. So extensions. Let's just check this fella out. I'm sure this is. Oh, we need. That's the GLS. Wrong extension. What is this called? That's the actual GLSL. Sorry, the Vulkan extension. So yeah, this is just build a dependency chain. Is there a way to just turn this on? So Vulkan. Okay, so. Okay, so a subgroup size. Okay, so I think there are minimal guarantees of Vulkan 1.1 physical devices must have. Okay, so we must have these. And so if you have Vulkan 1.1, I don't need to worry then, because I demand that everyone has Vulkan 1.3. Me, when escape reads terms wrong. So on so many different levels, his voice is disconnected from his brain. I know the yes, yeah. Yeah, if I read something slightly wrong, yeah, you're gonna have to like if I say like I'm going a bit quick. Thank you for the sparkles, dude. Wow, all the support. It's very, very nice. Right, I'm just gonna head to the loo real quick. I'll be right back, guys. Thank you for sticking with me. I'm just going to get our note on the screen. Because I am a professional streamer, only the fanciest of graphics are available, you know, for our BRB screen. So, there we go. I'll be right back, guys. Hello. I snuck in and got myself a cheeky cup of tea as well. So hopefully that's okay. I couldn't resist. I couldn't resist the tea. I had to grab one. That's why I was a bit longer. I don't know why I'm in the mood for like multiple cups of teas. I usually have one a day because my caffeine tolerance isn't the best. But yes, I couldn't resist. Cheeky cuppa. Yeah, having a cheeky cup of tea. Gotta have it. That's how it is. Sneaking a cheeky one in. Do you have your name on the bottom of your cup like Moss? No, I have a really fun cup though. On my 18th birthday, my uncle, I love this cup, got me a mug with the year I was turning 18, but for somehow he got me a cup that was a year like it was not the year I was born. And for some reason, I love that cup even more now because it's not the right year. It's got the wrong birth year, so it says 1992 written on it, with a load of 1992 facts of like, you were born in 1992. Here's some cool facts about 1992, and I'm like, I was not born in 1992. So I've got to, that's why I love that cup a lot. It's a good mug. It's a good mug. You drink like 4 cups of coffee a day. Jeez, I wouldn't be able to sleep. I would be so tired and so awake at the same time. I don't have that coffee tolerance. So yeah, I love my 1992 cup, the year I wasn't born. Still to this day using it. Yeah, born in 1983 indeed. That's the one. That's when everything else started in the world, right? Right. Okay. So let's reconcentrate on what we were doing. So we have the number of group. Okay, we were doing shader work groups. So work group size. How many invocations are in a single work group on this device? Ooh. Okay. I don't like energy drinks. I've heard white Monster Energy is like the best, but I've never actually drank it, so I don't really know. Supported, which is okay. So which shader stage group operation? Supported operations. Which subgroup operations are supported? Okay. Quad operations in all stages. Okay, so I assume that's... Okay, so group size, how many invocations are in a single work group? Okay, so that tells us... okay, so some work groups have some characteristics that are true on all hardware that supports functionality. I see femboy drinks. Invocations within a work group can be active or inactive. An invocation is active if it is, for what of a better word, active. What are you saying? An invocation is active if it is, for what of a better word, active within a work group. E.g., for example, it is doing actual calculations. Okay, so there's inactive and active. Okay, an invocation is inactive if the opposite is true. Sure. For one reason or another, invocation is not doing anything useful. So what cases for an inactive work group? Let's assume we've got a device that has a workgroup size of an integer greater than 1. Now let's look at the following compute shader. In this case, we are guaranteed that the inactive invocation in every... in this case, we are guaranteed to have an inactive invocation in every workgroup. Why? You ask. Well, if you specify a workgroup size that is less than the subgroup size. So, okay, so a workgroup size is less than a subgroup size. You are guaranteed to have an inactive invocation within a subgroup. Okay, so our workgroup is this, and we have a subgroup size on a particular piece of hardware, whatever that may be. Let's hit 64 or 32, depending on the hardware. Then yes, that makes sense. We're always going to have an inactive invocation. Now, remembering that subgroup is a way to expose a set of concurrent running invocations, we're basically committing ourselves to underutilization of the hardware in this example. If the subgroup of the device was 2, we are executing at 50% for 25. NVIDIA, which has a subgroup size of 32, we're expecting 3.2 capacity on an AMD, which is subgroup size to 64, and 1.6 capacity, which is bad, obviously. Even if you don't use any other part of the new subgroup functionality, you should aim to make your local group, work group be at least the size of the subgroup in most situations. Yes, this is something I'm very aware of, but I don't know much about that apart from that. That's why it's good to do them in 32 chunks. It is hard to know, though, which... Well, I don't know actually how hard it will be, but... You know, if you have different compute shaders for every type of graphic vendor, then... That might make storage of shaders quite complicated to handle. Anyway, because this, yes, you can over-optimize this, I think, as well. Let's just say that selecting the shader takes, I don't know, because you're touching the disk. In the worst case scenario, it might take, I don't know, 10 milliseconds. Whereas, like, if you were to just use the most basic setup where you use 32 and it's like you're not utilizing the AMD as much, you only lose like 2 milliseconds on in the worst case. So it doesn't make sense to do this. You know, not always the case, obviously, but that's obviously why profiling exists and why you should do that. Anyway, let's take the following snippets. So float some previous value set. If, for example, some invocations in a subgroup have x with a value less than 1, and some have values of x that is not less than 1, some invocations will enter the if branch and some will the else, yes, within the branch. All invocations that had a value of x that is not less than 0 will be inactive. Yeah. Sorry, let me say it again. Within the if statement, all invocations that had a value of x that is not less than 0 will be inactive. Likewise, in the else branch, all invocations that have values of x that is less than 0 will be inactive. Right, okay, so this is cool and all, but I need to know what to do with this. Who wrote this documentation? It's worse than 1980s stereo instructions. It is confusing. It just I think that was just saying, yeah, sometimes if it goes in here, it'll be inactive if it goes in. Yeah, if it's done this, it's going to be inactive here, which makes sense. Like, that's how computers work. But anyway, okay, let's change the music. I think we're getting repeating music. Let's not play Ratchet and Clank. Let's play. Yeah, let's play a cool track. It has to be this way. Let's turn this up a touch. Okay. This dynamic branching example is the exact difference between... okay, yeah, there we go. Okay. Let's connect back. Let's connect that back. Right, so Bonk T said... in a... Right, I'm just going to quote back what you said so we can actually connect these ideas, because this is kind of cool. Yeah, I knew today would be a lot of learning rather than actually coding. Where's our documentation gone? Did I close it? I hope I didn't. I must have closed it by accident. Very annoying. Right, let's get rid of this. Yeah, okay, so I'll read this anyway. In pure SIMD, you can't do... you can't take branches across the wave, right? You need to manually mask off lanes and make things still execute on every instruction in the program. SIMD is... Okay, so it's basically, yes, based on that thing that we were reading that I've got rid of, annoyingly. So, subgroup operations tutorial. So, subgroup... that's not how you type at all. Subgroup operation tutorial. Alright, cool. Let's get back to this. Yeah, I think I closed it by accident. Unless... Oh, it's right there. Whoops. Yeah, standing here, I realize... Okay, so an active invocation is a happy invocation. From the information provided above, I hope it's obvious that keeping invocations active, thus doing actual work, is the key to a happy GPU. Yes. Okay, so what are the subgroup operations that we can do? What I'm trying to look for, to be honest, is... Whoops, no, come back. That's really annoying. So what I'm trying to do, honestly, is... Let's just look at the subgroup operations that we have. I remember the broadcast sub-ballot ones were quite useful. So, subgroup ballot... I remember this one being quite useful. Each invocation contributes to a single bit, resulting in a corresponding... Now these ballot operations are returns the number of bits set to a value, only counting the bottom. Now, so ballot category introduces the built-in functions that allow invocations to do limited sharing of data across invocations of subgroups. Oh, okay, so let's look at the so subgroup ballot. I think this is what I want. All invocations are performing X. All invocations in subgroup are performing Y. Because sometimes I want to be doing something and sometimes I don't want to be doing something, right? But that is based on looks like a uniform buffer. Yeah, so if you do sub-ballots, subgroup ballots, what's the regular subgroup ballot? Okay, so each invocation contributes a single bit, resulting in a UVec4 to a corresponding value, and if I take that ballot and get the count of that fella, So that allows me to basically count up how many times we've done something, I believe. And if it exceeds a particular value, then we know that we want to do one thing in particular. And then I think we're good for then creating a new draw call, for example. So if yeah, I think this is these are the operations I was thinking of when I was thinking about subgroup operations, was subgroup ballot count and subgroup ballot. And the count, what is that? Kind of adds them all together, I think. What is this called? Subgroup ballot bit. So it takes in the vec4, returns the number of bits set in the value only corresponding to the bottom subgroup size bits. Right. Because I want to know what we're up to arbitrary. Because what I'm trying to do is count how many times we've done something in a compute shader. Only when we've done a particular type of thing. We should then do a... So what I'm trying to... That would make things one-dimensional again, I think. This might not be what I want, actually. Yeah, if we've done yeah, okay. So what I could do is go into our code, get rid of this. Because this is just going to be 1 now. Now this simplifies again. Now we need to extend this. I know I haven't done this in the... You might have to enable it very quickly. So subgroup operation. We then take, as far as I'm going to copy this code. As far I think I understand it, so I think I'm okay. I just want to not type it in, not make a mistake. We're not going to do y anymore. The instance count is what we're going to work out with this subgroup ballot thing. So as far as I'm aware, we want to be doing something like, obviously this is not correct. So we have a ballot. And what we're trying to do here is kind of just set up, as far as I'm aware anyway, this. And then that becomes the instance count. And we then have to assign this to a value. This is the instance count. Instance count equals this, and get rid of this. That can be used here now. Oops. And now we can do like a basic check where we can go like, okay, if this is equal to 0, then we run this, or if this is equal to greater than a... So you want to run it for 1. Yo, Emmanuel, how you doing? Yeah, it's going good. I think I'm trying to use subgroup operations properly. So if instance count is no, not 0, sorry. So if this is equal to, that's wrong, the last invocation. Actually, let's just assume we do this once. So we need to get the subgroup size, I think. And then we know what we're trying to, like how many times this is going to run. Number of subgroups within a local work group. No, you want the, that's the subgroup ID. How many times is this going to run? Is, as far as I'm aware, subgroup, we're just going to assume that we're not going to exceed a particular value right now. We want to set this to so that's our work group. Yeah, what's let me see. That's the subgroup ID. GL subgroup size, the size of the subgroup which matches the subgroup size. So I think if I just, for the global invocation, add that to that, if this is equal to the subgroup size. Okay, let's just see what that does. Obviously we're going to have an extension. Let's just turn that on, because that was available here too. So subgroup properties. Right, I'm just going to take this because it's not very glamorous code. Right. And we'll see how this goes, and if it goes well, then great. So, physical, yep. Physical features. Here we go. Okay, so yeah, I don't know if it actually exists here. Do we have subgroup operations in this thing? Like maybe. No, I'm just gonna go through and just make sure that it doesn't already exist as a boolean. Okay. Okay, so we have a subgroup here. And okay, yes. So we have subgroup size. So it looks like we can just turn on features here that we actually use. So we need the ballot ones. Which I believe... Do we have any subgroups here? No. Let's go back. In Vulkan 1.3, are these just subgroup size? Compute full subgroups. What is this? Is this just turn every compute thing on? What is this doing here? Structure, okay. Yeah, what does this turn? Okay, so... Because this turns on group size control extension. No. That's... Okay, so... Let's just run this, let's just do this the old way. This is the newer way. I just don't know what the booleans do off rip, so... we're just going to build the dependency chain. I don't think it really matters. Whoops, I think we lost the code due to a copy and paste. So I'd have to find that struct, figure out the boolean, and then, but at least we can simplify what we end up using here. So I don't like null PTR. Okay, so what do we have in this guy? We have subgroup size. Do we have to set the flags? This is what I thought we would do. So let's see what we've got here. I thought this would be a bit simpler, but here we are. Oh, okay, so it's just compute, yeah. So we set this for the compute shader because that's where we're going to use it. Subgroup properties. So that would be the compute, and then what else? The operations. So we need ballots. I assume basic as well. So subgroup operations. Just going to all basic in here as well, because I assume some of the things we're going to eventually use are going to be basic. Next is, what else do we need? Subgroup size. I don't know what that should be. I think I'm just going to look up this struct and just make sure that doesn't need to be set to a particular value. Maybe it needs to be 32, 64, depending on the hardware, right? Yeah, subgroup size. Okay, so subgroup size is the default number of invocations in each subgroup. It is at least one if any subgroup of a physical device queue. Okay, so I'm gonna. Okay, so it needs to be powers of 2. I'm gonna say the subgroup size is just gonna be an NVIDIA base. I'm gonna go with the safe 32, right? If it has to be at least one. I'm sure AMD likes 64, NVIDIA likes I think 2. What else do we need in here? This quad operations. I don't think we need that. Let's just check what it does. Again, is the boolean specify the quad operations are available in all stages? I'm going to say false for that one because I don't exactly know what it does. So if we can turn it off, that'd be great. We need to set this to initialize to that, and then set up the dependency chain of things in our little singly linked list, pnext, which I'm sure you guys have done before. So there we go. I can hear the sipping. Yes, yes, I am a tea drinker. So right, so let's just make sure this compiles. Alright, so I probably need to check that this hang on a minute. I just had a excuse me. Yeah, hopefully no one was watching. I just remember what these are for. Again, it's been a while. Let's just say workgroup size. We're still stuck on the same issue. I will get past this, I promise. Because the rest I think will come easy. I've learned a lot, but I haven't quite solved the problem yet. Yeah, I'm just gonna have to find this out. Compute shader. How do you know you're on the last invocation for a compute shader? Yeah, the problem is what I was doing then. You trying to count across a boolean. Sorry, off of a uint vec4, and all the it's a very fast way of doing basically an XOR operation. Well, that's what Bill. That's what the Yeah, all that's happening. Yeah. Okay, so GitHub has been having some problems loading pages as of late. Yes, it's unfortunately had that problem for a while. Alright, so the total number, get the total number of invocations. Invocations in a compute shader. Nope. This is the exact number of invocations you specify. That is the number of work groups you dispatch. Times by the number of work invocations per group. Okay, so that's all I need to know. So number of things I've dispatched is this is this times by invocations per group, and then we're done. Invocations per group. Invocation. Look, this is the current invocation of a shader within a work group. Right, so that is the number of work groups you dispatch times by the invocations per group. That's all I need. If I can get that specified by your compute shader's local workgroup counts. Local workgroup count, I think, is so local workgroup ID. Yeah, this times by that. That should be the last invocation. Meaning that we have an instance ID. Okay, so what I'm going to do then is set up this up so it does two things. So one invocation is just going to... How do I... Right, this is going to be quite straightforward. I think I can do this. Right. We shall see. I think that's it. I think that's... I went around the Mulberry boss, and then that was it. So I assume these have X's in them. We shall see. Where's instance count? Oh, no, that. Okay, cool. Now if I set this up so... Okay, so this might not work in the vertex shader, but this should work for our invocation. All I'm going to do is we're going to do the one, and so compute X invocation. Invocation, right? Get rid of that. I'm going to set this to 2, and then we should have a one draw call, right? And I think we're done after this. If I go into the vertex shader, How do I know which one's which? I do it by instance. So it should have worked. That should have done it. We should have one draw call. Let's see. Don't crash, don't crash, don't crash. The GPU, please, whatever you do. Okay, so... Okay, so we've lost the thing. So let's throw this into render doc. But it might have been my... Let's throw in a big hack, then. I just want to see... Okay, this doesn't work, apparently, but... What I'm going to do is just throw in a hack. If I say... this, I'm just going to get the first one. So if this is equal to 0, I'm going to say... Oh, 1. Got a 1, right. No? Really? Zero then? I don't know. What does it want? Oh, yeah, hang on. It should be +1. Yeah, okay, so let's try that again. So here's the hack. Oh, okay. Right, okay, so it's unstable. Which is understandable if one invocation makes a draw call and one invocation doesn't make the draw call. Which makes sense. So let's try again with this guy, which is only make a draw call on the last one. Oh, hang on. What happens if I don't have a draw call in an invocation of a compute shader? This is so annoying. You're gonna take another shower, BRB. So, well, have a good shower. Yep, so that never gets triggered. Now, if I get rid of this if statement altogether, what ends up happening? So annoying, gotta take 2 sips. What do you mean? Ah, yeah, sometimes it's 0. Other times it's 1. So if I set this to 1, we should have nothing. What? Really? We're basically back to where we were. Oh, so annoying you took pauses. I see what you're saying. That's funny. Oh. I did this completely. I'm so dumb. All right. Plus data index. Jesus. Idiot. Right, let's try again. Okay, there we go. So we have 2, but 1 is unstable. But 1 always exists, at least. Now, if I were to get rid of this, it should at least generate 2 draw calls. To do this. No, okay, it's generated 1. Interesting. No, it's not what I want then, so... Okay, so I think we're getting there. We're very close, actually. So 1 plus this If I do work group, let's do this again. We only want to generate... I feel like... I think what we need to do actually is make another compute shader. As far as I'm aware, I don't think we can do this in one go. The one compute shader does all the work, then we generate the draw calls from that compute shader's data that we pass in. So here's what I'm thinking, right? We do all the compute work for the actual thing, and then we can be like, all right, we have 70 particles. Okay, so we just want to do... I think we'd end up in the same situation, to be honest. Yeah, we would. Okay, so that was a bad idea. Okay, so that doesn't do anything. I don't think it ever hits that. Okay, so I'm just going to mess around with some values, okay? What happens if I do 0? So it's the first thing that always gets drawn. Start. Okay, so we only draw that guy. We don't draw, and if I say 1, we get 2 drawn, but 1 is flashing, which is weird. And by the way, that's the depth test, not doing the particles properly. That's happening there. You gotta remember these are quads, so it should work that way around. But yeah, I might have to turn on the depth test for these fellas because I've turned them off at the moment. So that's why you're seeing kind of like an eclipse effect. Anyway, Now if we set this to 1 again, does this do anything? Okay, so if I set this to 2, okay, so we still get the flashing, but if I get rid of this, I assume we have what? What do we have? Do we have 2 particles? Oh, weird. Okay. What is happening? Maybe this is not a good idea. And we can use this compute shader count thing, I guess. And do... I think we need a better way to do physics. Hang on, let me just grab some physics. From... So okay, so how does this work? Yeah, okay, this is all fine. This is doing the actual physics. But how do we know which one's which, right? It's all local variables. Oh, we have data passed in, that makes sense, okay. So yeah, we have a very straightforward kind of... This is what we need, basically, this. I just want to update the position with respect, because I don't know if I'm getting a true draw call here or yeah, these are fixed values, obviously, and we have this global ID instance, but I thought we could just add the value, but I think what's happening is we are adding 1 and then it's turning to 0. And then we get, like, kind of get back to where we... It's not actually disappearing. Let's... I'm trying to think how to do this. Alright, so if... Yeah. This is obviously just for demo reasons. And I think we're still going to get the same flashy effect, perhaps, but I'm not sure. What I'm trying to avoid here is sometimes it's equal to 0, sometimes it's not. So the lower one should be the flashing. I don't know what we're going to get here. Yeah. Alright, let's move on to a different song. Right, so sometimes it's 0. But as far as I'm aware, like, 1, it should be in here all the time, and another time it should be in here all the time. Like, it shouldn't ever be... And we still have the... I mean, we can get rid of this. Change this to 1, but I don't think... Then everything disappears. Because we draw this pair instance, so we only get 1. We don't do this pair draw call, but pair instance. The way to fix this would be GL draw ID RG R GL draw that. Then it would work. Oh yeah, we could have that guy. I don't think we need to turn on anything for this particular thing, but I don't know if it's enabled or required, we'll find out. Nope, okay, so interesting. I'm surprised that didn't work. Let's go into our game. We definitely sent this to 2. I like that you're using C style code. Yes. My code is very C style. I was very object oriented once, and I don't know. I don't think it gave any benefit. I would like my code to be readable to any, like, it's not my ultimate goal, it's just like a goal. Like my ideal coding standard is you've been learning C++ for 6 months, well, you can understand everything I've ever written, you know. You may not understand why it works, but you understand the syntax. Like, I don't want you to be like, oh, yeah, I've used this esoteric C++ standard thing that doesn't make any sense to anyone other than people who are obsessed with reading standard template books or something. Yeah, so my code is very mash and potatoes on purpose with C-like. It's C-like C++. Because here's the thing, right? I say, like, I want, you know, people who have been learning C++ for 6 months or 6 weeks even, you could say, to be able to understand this. This goes for me too, right? I also have to be, you know, the one who comes back to this code over and over and over again to understand it. So yeah, I keep it simple as I can. So yeah, I'm surprised this doesn't ever get to... Does this ever get to 2? Right, I'm going to throw this into render doc because I don't quite know what it's displaying. Alright, so let's throw this into render doc. And we have synchronization, we have log. Right, so we do this, and then we can turn these off. We obviously have to copy over the shaders. I'm saying it to myself because I keep forgetting if I don't. So now we've done that. The shaders don't always get copied to the release folder because that would be slower. At configuration time, it'd be kind of annoying if we constantly had to do this every single time. So I'm gonna yeah, okay. I don't know why this happened. We shouldn't have all this. I noticed all this came back all of a sudden. The reason I have to do that is because let's just copy the whole assets. I noticed that I was like on my hard drive I had like 10 gigs of like unused, like pointless storage. So that should run fine. Okay, there's render doc. Sorry, there's... Right, so let's see. Launch. And we're going to capture a frame immediately and then have a look. Actually, what am I doing? Let's do that again. Need to be looking at this. Capture a frame immediately, then do this. Right. Do we have more than one draw call? No. Really? I thought the invocations... Oh, hang on. I'm being stupid, aren't I? I just realised. If I want more than one draw call, I have to say that. Yeah, I have the buffer to do it, but I haven't said. Where is that? That would be in 2D renderer. And the indirect draw call is 1. It needs to be 2. Right, then I think that's going to work now. Right, in Jolt and GLSL, yeah. Yeah, trying. It's not going very well, but it is what it is. But we should have now 2 draw calls doing exactly the same thing. We won't. Yes. Okay. So that looks. Yeah. Okay. That actually looks different, but I think I can prove that with. If I go into render doc, launch this again. Well, I mean, I've learned a lot. That's like a big W of things like. All right. So if I do a capture. Immediately, we should have 2 of these fellas. Yeah, okay, so that's fantastic. Okay, so it is working. Meaning that when we have 2 things, or when we have 1 draw call, I was getting confused that my compute shader wasn't doing the right thing. But when I have a vertex shader that does things, not by per draw call, but per instance, then we don't get that result, right? Oh, again, we can't build. If it's open, so I think. How would I know? Okay, I'm just going to go back again just for real quick and just kind of take a screenshot of like what it looks like. Because there is a visual difference, it's just kind of subtle. I don't know if you guys can notice it. But this is when you have 2 draw calls. It looks like that. Yeah, okay, so I'm going to take a screenshot. just so I can remind myself of just like the density of pixels that we're seeing, right? Versus not drawing it, which would be Y. And bum bum ba bum bum. Right. Okay. So 1, I think we don't get that effect. So if we start look, oops, you know, yeah, it's completely different. It's not as dense. And even if we were to zoom out, they're like roughly the same. Yeah, you can see this is not as dense. Okay. VK Dispatch, Jolt, KHR. They let me become a Kronos member. I have a mate. Mates, I have great ideas. Really? You can? Wow, well done. How'd you join? Oh, I see. They let you join because of that. Dispatch, Jolt, KHR. Yeah, that is pretty based idea. Okay. That's my cheeky copper. I've got a cheeky cup of tea here. Oh, they should let you. Right. Thank you. Anyway. So invocation. Yeah, forgive me. Sometimes I'm like half reading. Sometimes I end up like skimming it and reading out loud the wrong thing. Yeah, forgive me. Right, now we have to battle the compute shader. If I set this to 2, does this work? Okay, no. This is the thing I'm confused by. Why does it do that? Sometimes it renders it, sometimes it doesn't. Like half the time. Even though that I'm saying for each... Yeah, if I do this for one instance... I have a feeling it's going to work. I'm not going to lie. No, it's not, it didn't work. What the heck is going on? Despite us saying that we have 2 instances of the same thing in the same position, why aren't you doing that? So we have 2 instances. Right, that wouldn't work at all because we don't... This is so complicated. If we had 1 instance of this, we would have to do this. I think it would work now if we did it like this. So for each instance, we would need to kind of like... You know... I think this will even work with a different position. So... Why are you flashing now? This is the thing I don't understand. Why isn't it not always doing that? And if I obviously do an instance index of 1, we have 1 first instance. I don't know, like 1. Let's just mess around with these values. I don't think that makes sense though. Yeah, that just gets rid of the first one, as expected. So we do have a different position, right? We have 2 draw calls, but each of them have the same data in, which I don't understand why. So we have 1 draw call. Even. I think. Do we have 1 draw call? I mean, like I said, we can do this with draw calls, but I don't want to do that with draw calls completely. Because it just seems like a waste to do a draw call for every particle on the screen. Like, I want to instance draw some of them, you know? We have the buffer. I just don't understand why. I think this has been tripping us up more than I realised. Which is good to know, because... Where's the 2D renderer? There it is. So we definitely have one... Do we... Hang on. Do we have to say, like, how many instances we have? But I don't think we should. That should be in the indirect draw call buffer. The actual data is in here. Why is it sometimes not there, though? It's like... I'm so lost, honestly. They're all GPU buffers as well, so it's not like we have a race... It looks like we have a race condition, but I don't understand why we would have a race condition. Oh, we have this twice as well. Wait, what? What do we have here? Oh, no. That's, yeah, we have 5 buffers because 2 are for the... Yeah, okay, that makes sense, sorry. Yeah, 2 are for... We're not reading anything in from our... Okay, so... Violation music, yeah, thanks. I'm glad you approve, Rock. Okay, let's just check these things. So, command buffer, offset. No, we don't have an offset. Offset. Ooh. Buffer. Oh, buffer count. Yep. And then, we have no offsets. We have draw call, max draw call count, which is 1. And we have a stride, which is just how to stride over that entire thing, which is fine. So we have, okay. Kind of stupid idea, but what if I put 1 in here? What does that come out to be? No, they're both 1. Interestingly enough, though, 1 exists there permanently, the other one doesn't. Huh. Why is that the case? Our compute buffer is literally filling up a buffer with 1 instance, but it has 2 pieces of data in it. Why is it the case then that... Okay. What is happening? So for both instances, it's like, yeah, it's doing it again there. So it's nothing to do with this instance index ID. That could be anywhere. It's like the data is bad. Maybe the data is too small. Hang on, let me make the buffer bigger. That could be it. This could be like, oh, I'm writing too much data. I thought I made it 64 bytes because I have 16 times by 16, so I thought it was like 2 times as big. Do you have GPU? Yes, I do. We have no... Oh, no, I don't in this case, actually. Sorry. I do, but I have had it for a long time, and I've still got this issue. Let me turn it on, though. You are right. We should be checking if forever this happens. Yeah, there's our synchronization. Yeah, let's go back to debug and turn on the logging and stuff. I don't think we've got a... So we got sync validation enabled and... Yeah, GPU AV. Maybe we don't have that. What extensions are those? Let me look at the validation layers again. Where's this? No, it's... Okay, so that's just me. Yeah, whoa. Bloody hell. Okay, alright. So we have GPU assist feature, we have synchronization validation. So let's see, is there anything else I need then? So I have this on. So maybe GPU AV, maybe this is a feature I need as well. Do I have this on? Yes, I do. Okay, so I have GPU assist extension. Yes, I have them both on. I recommend using _static asserts to ensure that all the non-dynamic allocations are fitting into a buffer. Yeah, that's probably a smart move, actually. Yeah, I know what you mean by that. So if hang on, though. Is that going to work? I don't think it is. Yeah, that's not going to work. Sorry, Rock. Because I'm filling up the buffers on the GPU, so we don't really know what we're writing to, and that's dependent on the VK dispatch number, right? So what I'm talking about, there's no way to know if I'm writing too much data in. The GPU will scream at me for a buffer buffer overwrite, but let me explain. I could be wrong, so I want to explain it. So make sure I am talking right. So each invocation here. So if we had like, we have one invocation right now, right? But let's just say we have like, you know, like this, right? And I've set the buffer size here to be 64, for example, right? I'm going to make this bigger. I'm going to make this by 256. This is not... now, I fill up this buffer in the GPU. On the GPU. There's no way to do a static assert to make sure this is big enough for what we're trying to actually fill. So that's unfortunately something we can't do. Obviously that's not going to be 111, but I am going to make it bigger just in case I am not having enough data. Oops. Why is my mouse being stupid? But yeah, yeah, it's just as bad, I think. Which is strange. It's like, I just don't understand the differences between the two. Especially because when I fill this buffer up on the compute shader, I'm explicitly saying, oh yeah, data 1 is this, data 0 is this. And we do have this in write mode. So we are writing to it. We do the transitions as far as I'm aware properly. And this struct only has these things in. And let's just check on the vertex shader. This is all like the same as well. Because it could be like a weird... So we have position. We have the same padding as far as I'm aware. So vec3, let's just check. This is all the same. Yeah, vec3, yep, particle position. And we have... So this is 4, 4 times 3, which is 12, and then we have another one, which is another 4, which is 16. So that's 16 bytes, which is fine. Then we have a buffer here that has the same old as before. It's read-only here. We have a particle buffer. But then we use the instance index, which should have been generated from the draw call indirectly. I mean the static assert, which was introduced in... Yeah, I know what you meant. Yeah. Don't worry. I understand the concept of static asserts. Yeah, it's honestly a good idea to make sure that it makes sense. Yeah. But I think, as far as I'm aware, we have 256 bytes. Let's just check this, right? 256 bytes. Sorry. This is going to be an obvious calculation, but we have 256 bytes. We have a struct which should be the size of 4 floats, which is 4 times 4, which is 16. 16 times 2 divided by 16 times 2 equals 32. So we should have 32. So it's not the buffer size. Even if I had 64, like we still should have enough room to be able to index into it. So that, And I think we would get a buffer out of bounds read anyway. So this is maybe a moot point. Because we have synchronization turned on for that type of issue. The next thing I need to figure out is why on earth does it feel like instance index is either 1 or... No. It's not that, is it? It feels like when we generate the draw call, for example. This is what it feels like. I don't know if it's true. This gets flipped to 1 or it gets flipped to 2 sometimes, right? It's like half and half. It should be 2 if we want instant render 2 things, right? This is 1. This is only ever 1. Because we run this compute shader once. We have 1 instance of it. Now, as far as I'm aware, doing this obviously is not permanent. This is just debugging code, but we have a buffer that we're reading in. We access them via our pointer, you know, through the buffer device address. This is basically just a regular buffer that has an array of stuff in it. We index from 0 and 1. We write stuff into that data because we have write access to it. And we're saying there's 2 instances, and we're going to use, you know, when we instance render something, we're going to use this buffer for the instance rendering, right? And as far as I'm aware, the vertex shader is taking in something that makes sense exactly the same way. We can almost compare these two, actually, 1 to 1, you know. The only difference should be this is a read only. So I'm just going to paste this in just so we can see it exactly. So this is the compute shader version. And yeah, it's read only, it's particles, it's taking in the particle data. This is the same struct, exactly the same struct. So when we do instance rendering over that, we do take the pointer here, we take that out and go, okay, this is for 0 instance it's position, for 1 instance it's a different position because we have a different data in that buffer. Okay. This is all well and good, except it doesn't work. And I don't know why. I literally don't know why. The command buffer, let's just go through this as well. This is another buffer that we're writing to. This is building up the draw command. And I don't know, maybe you can't do this. Maybe what I'm trying to do here is an indirect draw call instance rendering. It's just not possible the way I'm doing it. But I don't know why it would give me the instance variable if it didn't let me do this. I don't know. I literally don't know. This needs to be removed, to be honest. I never use it. When I see all your code, I can't imagine what it takes to make simple animation for 3D in Vulkan. Oh yeah, it's animation's kind of tricky. I haven't actually done it in Anger yet, which I will at some point, but soon. It's a lot of it's just parsing the file correctly and then selecting the type of skinning that you want in the shader. Whether you want step-based or like what's typical. Step-based is not what you use all the time. That's very specific, actually. Standard animation, right? You would smooth between them in a skinning shader, and then you'd pass that over to another shader, which would do something else. It is kind of tricky, but it's like standard practice, so it's not exactly hidden knowledge. Yeah, there we go. Yeah, x equals sim time. Yeah, exactly. I just don't understand why this would be the case. What? I need to ask myself this question. What am I not understanding? As far as I'm aware, I feel like I'm understanding everything. I don't... There's nothing that's like kind of confusing to me right now. I'm doing the simplest thing. Do you know? This is the thing I don't quite... So I don't know where the error could be in... I've clearly not understood something. But I'm trying to figure out what that might be. Let's just check my pipeline, I guess. Maybe it should stay a shader storage buffer object. Let's just check our yeah, let's just take our pipelines, I guess. Vulkan is really the kind of thing you'd use to create an easy API like OpenGL. Yeah, in my honest opinion. There exists a thing called GL to VK. Yeah, I see what you're saying. But wouldn't it be the VK? Oh, GL on VK. I said in VK. Sorry, I misread you. Surprising no one. Hi JTag, by the way. I don't think this would help, honestly. It's not even Vulkan that's getting in the way, honestly. It's like indirect draw call concepts which exist on both, right? I actually don't know, but so we do a compute shader, we make it read write, which I guess it could be just write. I actually don't know why I said that's a read write. I'll try it, see if that makes sense. Now, here's where I might have made the mistake. So it was in write mode, and so when it's a shader storage buffer object type buffer, I don't think it's a vertex shader. Sorry, what is the destination? Hang on, let me just check. I'm just a bit confused here. Okay, these are the stages. That won't be it. Maybe shader reads wrong. What's the access type? Let me just check my other my other buffers that do this, because I've kind of set this up to kind of automate. So I'm just going to make sure that this is the same. So when I create buffer, oh, okay. So let's just go into Skybox. This is simpler. Create buffer. So there should be a buffer here somewhere. Let's just actually. Nope, sorry, my bad. And let me get rid of that. Create bindless buffer. Right. So this is the typical buffer. Okay, so here we go. That's what I was after. And in here I say that, yeah, that's fine. But when I actually do the pipeline stage, what do I do? So OpenGL, you are not able to do a lot of optimizations. Oh, Rock has said, I mean, Vulkan is way lower level than OpenGL, as is D3D, yeah, Direct 12. So it is what is used to create a higher level API, such as Vulkan or other similar APIs. Yeah, I see what you're saying there. Like you would use Vulkan or I think people have. There's a couple of graphic engineers who have to like try to make a try to popularize their version of an abstraction. I think the most popular right now is like something like well, I know someone who uses it, so I don't know how popular it is actually. This is more anecdotal than anything. So I think it's BGFX, right? It's just an abstraction on top of everything. It's even higher level than like OpenGL is. But yeah. I don't think anyone's actually succeeded though. Honestly, I'm not gonna lie. People have like tried, and it almost seems like they failed to do this. So I'm gonna go back to this again and just see, like, okay, using that, what pipelines have we set up here? Oh, I guess we don't care. We have 1 giga pipeline, I guess. Yeah, so where's begin rendering? I think this has the... This is the dynamic rendering. Where's the... Yeah, that's what I'm after. Okay, so... This is just for the frame, though? No, I don't think this is right. Yeah, this is just for the frame. Like, the actual images themselves, not anything else, really. Yeah, I think, yeah. Oh, that's true, actually. SDL and... Yeah, SDL is a more popular one, I think. Alright, guys. I did say it was a shorter stream, so I'm going to end it here. I'm going to give you my link to my Discord server. If you haven't joined it already, please feel free to join. Thank you all for taking your time out your day and helping me and talking in the chat. It's been a pleasure, as usual. You've all been wonderful. I hope you mind me haven't been bothered by me misreading your chats every now and again. It's you know, it's a common mistake that I make, but yeah, I do appreciate you all. I hope you all have a fantastic rest of your day. I will work on this obviously off stream, but for now, yes, it is coming to the point where I can't stream anymore, basically. There are forces outside of my control in real life that mean that the stream has to be short no matter what. So yeah, I shall see you all shortly. Well, in the next one at least. So yeah, have a good rest of the day, guys. All right. Bye, guys. Bye, 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 bye.